First, find the mass of the graduated cylinder. Use the pipette to fill the graduated cylinder until the bottom of the meniscus is at the 10 milliliter mark. The meniscus is the curve at the surface of a measurement of liquid in a container. It occurs because of adhesion, the attraction of water molecules to the container, causing the liquid to climb up the sides of this pipette. Measurements should always be taken from the bottom of the meniscus, with the meniscus at eye level. The measurement of this sample of water would be 0.99 milliliters for the final volume. Mass the 10 milliliters of water along with the graduated cylinder. The mass of the graduated cylinder, which we measured earlier, can be subtracted. This is the density formula. We can plug our measured mass and volume in to find the density of water. Mass the volumetric flask so that it can later be subtracted from the mass of the sugar dilution. Use the pipette to take up an amount of 20% sugar stock solution. A stock solution is a solution of a known concentration that is diluted to make dilutions. The volume of water originally in the pipette is the initial volume. The volume in the pipette after releasing some water into the volumetric flask is the final volume. Subtract the initial volume from the final volume to get the volume of the water that is now in the flask. Fill the volumetric flask the rest of the way to the mark, which is at 25 milliliters, with water. Make sure the bottom of the meniscus is at the mark. Take the mass of the flask along with the 25 milliliter dilution inside. This entire process should be completed 3 times so that we have 3 sets of data that will account for 3 different concentrations of sugar solution. This is the equation we will use to determine the concentration of each of our dilutions. C1 represents the initial concentration of our stock solution, which in this case is 20%. V1 represents the volume of stock solution that was in the volumetric flask, which we measured by subtracting the initial volume from the final volume in the pipette. C2 is our variable, and V2 is the amount of total solution in the flask, which is 25 milliliters after we diluted the stock solution with water. This is what the equation looks like once the values from our trial are plugged in. For challenge 3, we will be trying to determine the concentration of an unknown solution by comparing the data from this trial to the 3 trials in challenge 2. The unknown solution we will be using is unknown number 943. We will do the exact same procedure we previously did with the 20% stock solution with this unknown solution. Plug your measurements into the density formula to find the density of the unknown solution. Then write a proportion with the density and concentration of one of the trials from challenge 2 and the density you just found of your unknown solution. This will give you the concentration of your unknown solution.